Of course. So my name is Markus, and I'm here to present this survey paper on the use of augmented reality and mixed reality and so on in terms of industrial machines. And my co-author couldn't be here, but it's Taufik. This is how it looks. So let's get into what is then heavy machineries and this type of vehicles. What am I talking about? And from being a kid, and maybe many of you as well, has had these kind of big machines that are doing different things that you want to try and run and so on. And this is what this paper is about, how to interact with those, say. And the difference between, for example, vehicles and so on is that they are often performing a task in parallel to driving. Of course, it could be static vehicles as well. Some of them are very specialized, like small factories doing a specific things and having a lot of automations in them, a lot of process control. Some of them are more like generic, so they're supposed to do multiple things, like the excavator that can help you with a lot of tasks. Often you're working with persons in the close area to what you're doing as well. And as we can see in vehicles and in all areas, let's say, we have more and more software. And also in these kind of this is actually car figures, but the same thing is for heavy machineries as well. All new features are being done through software. All new innovations are being done through software at many levels and to higher and higher extent. And this makes us having more and more digital type of interaction with all of these things that driving the machine, climate control, production support information and graphical information systems, service-related things. Then you have apps and you have add-on implements that you add to the machine, and it also has software-driven functionality that it needs to interact with, and so on, back office things and so on. So that moves interaction in this kind of vehicle to be a digital environment, where you have the display as the main thing that you interact with, and then you have like joysticks and a lot of buttons to control the things. And in reality, you get some issues with it because, for example, you look up or down in different areas where you don't see the display, so you miss what is presented to yourself. Or you get these kind of systems with a lot of add-on equipment, so you have a lot of screens. Actually, in this case, also the operator said, I don't like screens, I don't use them. And I think he had 2 or 3 more screens in the cabin on top of this. An earlier study that I did was to use eye tracking in this kind of cabins to see how much do they actually look at the displays and so on, which was very little. I think the highest one was like a few percent, it's like 6%, and it was for reversing cameras. It was very much in line of sight with other things he was looking at. And on some of them it was like sub 1% and so on, which meant that is good in one sense. You don't want to have them looking at screens, but it also makes them miss information, as I said earlier. And this is similar also to other studies with machine operators. And then we get into these things with then the divided attention. And if we put more and more information in there that you should look at, we have this with divided attention that might miss things. But we also have this that maybe we can help them by showing things so that they can actually operate the machine more safely. Because hitting into objects or hitting into persons is one of the more critical things. And yeah, things like this can happen. And then, since we are at VRK, we get into this with how can we then take this information that we can support them with when we are connected to a lot more sensors, a lot more data and other things, to support the user in a better way for production information, but also for safety information. And of course, then we have all of these visions about what could augmented reality do for us and head-up displays and things like that. But what is the current state, so to say? And that was what we are trying to survey in this study. So we did a literature survey. We had Google Scholar as our source for data for this one. We tried to add a lot of terms for about augmented reality, mixed reality, and things like that, together with a bunch of specific type of machines and also generic words for different types of different machine types to get hopefully as good coverage as we could. Based on checking the titles to see is there about augmentation or do they have a user aspect to it, because we didn't want to have all the technical articles. We got into 233 articles and then sorted those down to these 39 articles that were actually really about the user and augmentation for that, which we then checked in detail that are included in the paper. So for then different types of visualization, what was used is the most common one was the head-down displays with video-based augmented reality. This was most studies and also most studies in real-world situation. And then of course head-up displays and head-mounted displays, which is more that kind of see-through mixed reality thing, which were more common in simulated environments actually. Probably due to technical limitation that with head-up displays they are not. I mean, a car display you cannot use that in the same way because they're looking straight ahead all the time. For an industrial vehicle, they are too small and you cannot mount them in the same way. So it's very few and very expensive equipment if you want to do it in a real machine. Nothing really commercially available. Head-up displays also, or head-mounted displays also has a problem. For example, HoloLens and so on, to use that in these kind of machines, limited battery time. Also requirements on helmets and so on, which hasn't been on until I think HoloLens 2, where something has been really approved and built together. And then something with projection displays and also mobile devices, which could be a problem to holding it, of course, for a prototype thing, but otherwise you need to have both hands in the vehicle. And then simulated augmented reality, then going into augmented virtuality and so on, especially for remote operation, remote control. Where you have the whole thing in virtual environments there. We included two types of, so say, in-cabin and teleoperation. And there is one difference is that when you have teleoperation, you have the lack of awareness that you have, that you cannot look around in the same way. So you want to use the augmentation to counteract that. But otherwise it's a lot of similarities as well, because you want to show process information and things like that. But it's more than video based and you have the screen already. A few type of basic cases that we digged out is then, one is navigation and guidance. We know this from road vehicles, for example, but it differs in these areas because it's more like precision navigation, that you want to follow a certain track, for example, if you are on a field and you want to see the coverage of the area being, for example, fertilizing or that kind of operation. It could also be, as in the lower side there, to see things that you cannot see normally. That was a snowplow, where they were able to show the road and the size of the road, so you can see that even when it was covered with snow. Interestingly, with this is that from the studies, the mental load was higher. The precision was better, but the mental load was higher with these ones. So they needed to check on different data, probably so. And then we have some other where you can see things, for example, in this lower left, where it's a forklift. It's difficult to see the picture, but you can see then what you cannot see in real life, so to say, how the forks, how are they going into the pallet and so on, to make more controlled movement and avoid hitting into things and so on, which was also helpful in a significant manner. Next thing is then to take away things from the real world, meaning then the structure of the machine, for example, because you have big machines with a lot of metals and so on that hinders your view. So then you can make it more transparent using augmented reality, which was good and appreciated, but it's also, if you had it too good, so you took away like most of the things, you could bump into more things because you didn't really see where you have the machine anymore. So then an alternative way was to try the more point clouds, so you can actually see something about the area around your machine, but still have the whole machine visible. Process data, of course, to show what's on the display more or less in line of sight in front of you. And there we go from having this more direct things that you could see here as well, but having more textual data and so on. This is actually from one of the few real world studies using head-up displays to having more refined and more design interaction, which is these right pictures where you can then see data on the road. This was a road compactor, so you can see where do I need to compact more, what's the temperature and so on. So to make it a little bit more immersive, which also kind of showing that this kind of interaction was more perceived than the other one in terms of how much they liked it. So it's a lot of more work to do in actually how to visualize all the information we have. Then we have warnings and notifications about is there an imminent danger of hitting into something, or what's the correct lifting path and so on, excessive loads and these kind of things. In comparison to what I said earlier about this higher mental load with these navigation things, this seems to be appreciated with less mental load, and also more that people notice the warnings more and reacted to them better. But of course it didn't help at all, because if the user is focused on the task, they still miss the things even though we present it in line of sight, so to say. So it's not a fail-safe method, but it's one aid. Then we have something about what try to collect a little bit of the design guidance that the paper gave. Its colors are appreciated. We saw in a few papers, which could be also a problem to have them in the scenery in the correct way, because you're in light cabins and things like that. And then there is a lot of debate about placement and where to put the information. Should it be on like the lower left corners, as one paper said, and other papers said other things. So it's not really going into any clear direction there. And then to have this grouping of information and showing the right amount of information was also mentioned at several places. One thing that I haven't covered earlier was this with having it for training of operators, which seems like a really good thing. And also people that gives feedback this is good for novice operators. I know what I'm doing anyhow, but for novice operators this could really help and so on. The studies so far are quite small, especially when we come to real operator studies, which was like only a third of the papers, and then it was like 6 users in average for those, some with less, some with more. So that is a limitation so far, and the responses sometimes differ. Of course, there's a lot of diverse types of machines, so and also diverse type of interactions. So it's quite difficult to make any clear conclusions from the body of research so far. And they're sometimes saying like different things, so they have no significant performance result on one study, and another study has quite significant results and so on. So there is a need for more studies and more controlled studies. But in summary, it is very promising to use these kind of technologies in these kind of industrial vehicles. We have shortened response time and so to say better performance. We have also this with the ergonomical situation, because they have a lot of looking up and down and so on. So that's something that this can help for. It is appreciated, and as I said, it has with potential with training. But the technology, as it seems, is still lacking, especially going into real world situation. It's a lot of simulations done already, even simulating then the augmented content, and then also about integrating it with other things, sensors and data and so on is also more in the visionary parts rather than what has actually been evaluated. And as I said, it needs to be more studies to really make any firm conclusions. I think that's all. Thank you.